Okay, the second lesson, we're going to deal with radical equations. Okay, when we're dealing with radical equations, first of all, you need to know what a radical looks like. A radical looks like this. It's also called a square root or a cubed root. It's a generic term for any kind of a root kind of an equation. If we don't have a little number in the ditch, then this is a square root. Okay? If we put a number in the ditch, such as a 3, now this is a cubed root. Okay? In these equations, we're not going to actually do the square roots or do the cube roots. What we're going to do is undo those roots so that we end up with an equation to be solved that doesn't have any radical in it. So if I have a radical, which is a square root, squaring it undoes a square root. If I have a cubed root, cubing it undoes a cubed root. Because what we're doing when we're squaring it, we're saying this radical times this same radical. Cube rooting, when we cube it, it's this one times itself 3 times. Okay? So these undo each other. They're opposite actions, just like addition and subtraction are opposite. Multiplication and division are opposite actions. Squaring and square roots are opposite actions. Cubing and cube roots are opposite actions. So that is what we have to remember when we're dealing with radical equations. Is we have to undo the radical. But before we can undo the radical in radical equations, we have to first of all isolate the radical. And then the next step is to undo it. Undo the radical. And then, after that, you continue solving. Okay? So and then we need to check for extraneous roots. Extraneous roots are roots that are incorrect, that are caused by the squaring. And so sometimes when you square, you end up with answers that are not true answers, and those are called extraneous roots. So let's look at some examples of this. If I have the square root of x is equal to 4, you're going to look at me and say, well, what number, if I take the square root of it, equals 4? And many of you will know that that is 16, because the square root of 16 is equal to 4 times 4. In other words, what number repeated, therefore the answer is 4. So the square root of 16 is 4. So therefore my x is equal to 16. Okay? Square roots are like absolute values. They produce a positive answer every time, unless we tell them to do the negative. If we tell them to do the negative, then this would become a negative 16. So we have to think about those things when we're looking at it, although that would not be a good thing to do that there. You have to do something outside to get a negative, okay? So as we look at this, the square root, let's go through the process. The square root of x is equal to 9. Well, to undo the square root, you're going to square it, and if you do it to one side, you have to do it to the other side, because in equation solving, you must do the same thing to both sides. So the square undoes the square root, leaving you with an x, and it's equal to 81. Because 9 times 9 is 81. Now let's look at one a little bit harder. X plus 2 is equal to 5. Okay? Again, my square root is already isolated because everything is inside my square root. So all I have to do is square both sides. And squaring undoes my square root, leaving me with x plus 2 is equal to 25. Subtract my 2, and I end up with x is equal to 23. 23 plus 2 is 25. The square root of 25 is 5. So therefore, I know for sure I have the right answer. What if I said the square root of x plus 2 is equal to -3? Now, say I didn't notice that I have a square root equal to a negative, or I forgot that that's not possible because a square root is assumed to be a positive answer. If I didn't remember that and I squared this thing has to be put in parentheses because the -3, that whole thing has to be squared. And so -3 times -3 produces a 9. The square undoes my square root, and I have x plus 2 equals 9. Solve for my x, and I have x equals 7. But is that true? Let's try. I have square root of 7 plus 2 is equal to the square root of 9, which is equal to a positive 3. But what did I start out with? I started out with a -3. 3 and -3 are not the same number. Therefore, this has no solution. Okay? So keep that in mind. When my square root is put equal to a negative, I'm going to end up with an extraneous root. Because square root, by definition, is considered a positive unless we state differently. Okay? Now let's look at another one. Okay? I have square root of x minus 4 plus 10 is equal to 15. Notice my 10 is not under the square root. It is outside the square root. So therefore, before I can deal with my square root, it must be isolated. Because if I try to square this whole thing, then I'm getting into something that you haven't even learned yet. So we're going to have to first of all isolate it by subtracting 10 from both sides. And we still have my square root is still here, and that's equal to a 5. Now square both sides, and I end up with x minus 4 is equal to 25, because 5 times 5 is 25. Add my 4, and I end up with x is equal to 29. And now, think about it. If I put it back in, 29 minus 4 is 25. Square root of 25 is 5, and 5 plus 10 is 15. One more before I'm out of room. Now this is the same kind of thing that we've been doing. First thing we're going to have to do is isolate my square root by subtracting the 10 from both sides, leaving you with that x minus 3 is equal to a negative 2. Whoops, what do we see here? I have a square root equal to a negative again, and if you remember, that one is no solution. Anytime it's equal to a negative, it isn't going to give you a solution. If we went ahead and solved it, we'd have to check it, and we would find out that it is not possible. Okay? One more of these. And then I think I'll do one that's hard. Okay. I have the cubed root of x minus 4 is equal to 3. So the first thing we have to do is undo that cubed root. Remember at the beginning I said a cubed root and a cube undo each other? So I'm going to cube both sides, and that's going to leave me with x minus 4 is equal to 3 cubed is 3 times 3 times 3, which is 27. And now we will add 4 to both sides, and we end up with x is equal to 31. 31 minus 4 is 27. Cube root of 27 is 3. So it gives us an accurate, correct answer. Let's do one more. Okay? Now remember, the first thing we need to do is isolate that square root. So to get there, first of all, I'm going to eliminate my addition by subtracting that same thing from both sides. That's going to give me 4 times my square root of 2x minus 1 is equal to 8. Now, the square root is still not isolated because I have a 4 multiplying that. So my next step is to divide by my 4, and that eliminates that, leaving me with my square root 2x minus 1 is equal to 2. Now square both sides, and I end up with 2x minus 1 is equal to 4. Add my 1, and I have 2x is equal to 5. So divide by 2. X is equal to 5 halves. And I can put it back in and check it. 2 times 5 halves would be 5, minus 1 is 4, square root 4 is 2, 4 times 2 is 8, and 8 plus 7 is 15. So it checks out, all right? And I'm sure you will have questions on this one, because again, these are some of the harder things we're doing in this entire course is right now. So we'll get it over with while we're fresh, and hopefully we'll remember it and be able to use it in the future. Now I'm going to split it right here because the second half of this assignment really has nothing to do